Welcome everyone. Welcome everyone sorry for the interruption. So we will be using 12x minus 4 is greater than 0. So now you just solve this inequality, which is going to give you 4 over 12. So it's going to be greater than 4 over 12. You can simplify this further and write x is greater than 1 over 3. So that's going to be a final answer. So solving the step part B says to solve the equation log 5x 12x minus 4 equals to 6 over log x 125 plus 1. So let's just solve it. Log 5 12x minus 4 equals to 6 over log x 125 plus 1. So you know that 125 is going to be 5 cubed, right? So now, okay, so now what we do is, so we can make this the denominator of this. If we move it to the top, we'll get log 125x. So let's just do that here. So log 5 12 minus 12x minus 4, 12x minus 4 equals to 6 log 125x plus 1. So there we have that. And now what we do is we need to make sure that it has in the same base. So we know that log 5 120 12x minus 4 is going to be okay. Before we convert it here, so yeah, that's one of the things. Before we convert this to the base, we can make this to be log 5 12x minus 4 6 over log 125, or else log x, sorry, log x 5 cubed. So that's how it works. So that's 5 cubed, right? Now you bring down the 3. So that's one of the properties of logs, that you can bring down any exponent as the coefficient of your value. So you can bring down the 3 log x5 plus 1. Now you bring it to the denominator to the top, so then your base will be the same there. So we will have 6 over 3, which is going to be 2 log 5x plus, let's keep it in the same base, log 5 5. So we can convert 1 to be log 5 5. And now we will have log 5 12x minus 4 equals to okay, now we can make this to be log 5x squared plus log 5 5, and again log 5 12x minus 4 equals to log 5. So the property here we'll use is going to be, when you add any two logs with the same base, you can multiply the values values you're logging. So here we get this. Now we can directly compare these two into parts. So like now we will have 12x minus 4 equals to 5x squared. So then 5x squared minus 12x plus 4 is going to be 0. So what I did is I just moved this side and then made it like this. So now you need to show how you are going to factorize this. So now you can see you can make the factorization works like this. So 5 times 4, you can take it as 20 to 10. Okay, I'm just doing the prime factorization for now. So you need to make sure that negative 12 is within these factors. So that should give you 5x squared uh, minus, okay, it should be, yeah, minus 10x minus 2x plus 4 equals to 0. So now as we have separated the middle part, now we can directly do the factorization. 5x would be x minus 2, minus 2 will also give you x minus 2. So your factorized form will be 5x minus 2, x minus 2 equals to 0. And now what we have here is x is equal to 2 over 5 and x is equal to 2. So those are the two values of x we found. So hope you got it. Okay. Now let's move on to question number 9. So 9 is going to be okay, whenever you see something like this, you just remember that this is going to be something to do with the calculus because you have curves and the straight line. So here the point A with x coordinate 2 lies. So they told that A is going to have a 2 and some value of y. Lies on the curve y equals to 4x root 4x plus 1. The diagram shows the tangent at curve A. Find the area of the shaded region between this. So basically the shaded region. So how are we going to go about it? So the point here is you can see that there are two regions you can consider. So the whole region of this, so which is the triangle, the whole region of the triangle, and the region where this curve under the curve. This is the region under the curve. So when you subtract the region under the curve from the, so let me give it more elaborately. So the red part is going to be A2, green part is going to be A1. So when you do A1 minus A2, you will get the area shaded. So that's our idea, the fundamental idea of how to go about it. So first, to do this, we need to know the y coordinate of A. So how are you going to find that? We just substitute the x coordinate of A into the y curve because it's intersecting the curve. So y, so let's just write when x is equal to 2, y is going to be equal to root 4 times 2 plus 1, which is going to be 3. So as you can see, this is on the positive x-axis. You take it to be 3, the positive 3. So then, therefore, the a coordinates will be 2, comma 3. So now what we have here is that the let me get some space over here. So I understood the A1 and A2 and how the basic idea. So this length will be 3 because from 0 to the 3 here, so this y1 is going to be 3. So that's going to be 3. And this length is going to be 2. But we don't know what is this length, the full length of the base of the triangle. So to find this length, what we do here is, okay, let me see. Okay, what we do is we need to first find the equation of the tangent. So the next step is to find the equation of the tangent. Equation of tangent. So what is it? How do you find the equation of tangent? So the tangent is you can call it the gradient. So the gradient equation, you use the differentiation formula. So what you do is dy over dx, and that's going to give you, okay, let's first write what is y. Y is equal to root 4x plus 1, which is, you can write it as 4x plus 1 half. Now dy over dx is going to give you bring down the power, write the equation as it is, reduce the power by 1, and you need to remember to differentiate the inside. So that's going to give you 4. So that's going to give you 2 times 4 Okay, in simpler terms, we can write it as 2 over root 4x plus 1. So now what is the catch here is this intercept. So this intercept is going to be, so this is the x-intercept of the line. So where the line meets the x-axis. So at this intercept, y will be 0. You need to find the coordinates of this point to find the distance from the origin to this point. So when y equals 0, we just write, so let's say this is also the, so what, 2 over, or dy over d, okay, yeah, it's fine, y equals 0. So what we are assuming here is we are going to let y equals to 2 over root 4x plus 1. So then when y equals 0, x is, okay, so now 2 over root 4x plus 1 is going to be 0. So now what you do is you can write this as 2 4x plus 1 negative half. So now 4x plus 1 negative half is going to be 0. And then, so now what we do is we can bring the half to the other side. That's going to give you again 0 plus 1 is equal to 0. X is going to be negative 1 over 4. So you know that the x-intercept of the tangent, x-intercept of tangent is going to be negative 1 comma negative 1 over 4 comma 0. So now you have the information of this part. So negative 1 over 4 comma 0. So it's good to annotate on the graph so that you can easily understand. So now the distance over here, so the distance over here will be negative 1 over 4. So the total distance, so we take the magnitude of this distance, which is going to be 2 plus 1 over 4. So now we find the area of the triangle, which we are intending to find. So that's A1 from our case. So area of the triangle is going to be the A1. So how do you find it? You use the half times base times height formula. So the base is going to be 1 over 4 plus 2, and then the height is going to be 3. So now what you have is half times, this is going to be a 9 over 4 times 3. So that's going to give us 27 over 8. I believe that's the one. Yeah. No, 27 over 4. Once again, I'll just verify that. Oops. Did we make any calculation error here? Okay, no, I think we don't need to write it in this format. And then this should be going, so let's just leave it in this format. It's better to understand. For simplicity, I think it's easier to understand in this format. Negative half times 4. So now you just write half times 4 4x plus 1 negative half equals to 0. So now when you move this to the other side, oh, okay, yeah, sorry. So this is basically not the equation of the line. It's going to be the gradient of the line, sorry. So this is basically the gradient. Okay, that's where I made the mistake. So that's going to be the gradient of the line. So when you want to find the gradient, we just substitute the values we have on the gradient. So 2 is the value we have. So the dy over dx at x equals to 2 will be 2 times 4 times 2 plus 1 negative half. And our gradient here would be 2 over 3. Yeah, now we get it. So now the equation of the line will be, you can use the y minus y1 equals to m times x minus x1. So here what we do is y minus the point A also intersects the tangent, right? So you can use that point A as a reference. So y minus 3 will be 2 over 3 x minus 2. So now when y equals 0, so now when we are finding the x-intercept, when y equals 0, now this is going to be negative 3 equals to 2 over 3x minus 2. So x minus 2 is going to be negative 3 times 1.5. That's going to be negative 9 over 2. And x is going to be negative 5 over 2. So that's your point. So this point, sorry, so this point would be uh, negative 5 over 2 comma 0. So now we know that this distance here will be 5 over 2. So the total, so the area 1 would be, again we use half times base times height. The base is going to be 2 plus 5 over 2 and then plus times 3. So that's going to give us half times uh, 13 over 2 times 3, which is going to give us 39 over half. So yes, so times, you will get 27 over 4. So here you have half times 2 is going to be 8 or 4 over 2, which is going to give us 9 over 2 times 3. So that's going to give us 27 over 4. So now to find area 2, that's pretty straightforward. You need to just know this point from where it starts, which is x is equal to c, x from x coordinate here to here. So that's basically area under the graph. So area under the graph. So this is, so you need to find the x-intercept of the curve. X-intercept of curve is going to be y. So when, so at x-intercept y equals to 0. So that's the idea. So when y equals to 0, then you have 4x plus 1 equals to 0, x equals to negative 1 over 4. So that's your x-intercept. which is this point over here. So which I highlighted in red. This is negative 1 over 4, 0, comma 0. So now you plug this into your definite integration. So area 2 will be just the integration from negative 1 over 4 to 2. So 2 is the end point. So from this to 2, and then you just do root 4x plus 1. So root 4x plus 1 dx. So that's going to give you, so like let's just write this in exponents form so it's easier to evaluate without the calculator. So 4x plus 1 half dx. So now you will get you add the power by 1, which is going to give you 3 over 2, and then divide that by 3 over 2, and do not forget to differentiate the inside function, and then from negative 1 over 4 to 2. So now when you plug in your values, so you just plug in your values 4 times 2 plus 1, 3 over 2 over 3, okay, 3 over 2 will give me 6. So I just cancel this. 2 times 3 is 6 minus uh, now 4 times negative 1 over 4 plus 1, 3 over 2 over 6. So the answer you would get from here, it's going to be 9 over 2. So when you evaluate everything, you'll get a final answer of 9 over 2. So therefore, as we told, the area shaded is going to be A1 minus A2, which is going to give me 27 over 4 minus 9 over 2, which is going to give me 9 over 4. So that's your final answer. I hope you understood. Just a quick catch over here that this represented the gradient, which I misinterpreted. Sorry for that. And then you just follow the steps as you just need to know which one you are finding at in each stage, and then just follow through the steps. So let's move on to question number 10. So this is a trigonometry question, and so whatever is given here is not applicable for this question because this is just the domain. And you're asked to show that this expression equals to secant theta. So whenever you're proving, as we know that we need to write the LHS and then we need to prove it to be equal to RHS. So now let's take LHS to be the sine theta over root cosecant squared theta minus 1 plus 1 over 1 plus tan squared theta. So I've just included the identities over here. So you need to use these identities to prove something to be equal to something else in a trigonometric question. So here we have sine theta. So what's root cosecant squared minus 1? So cosecant A is equal to 1 plus cot square A. So here when you bring over that, so you'll get cot. So what's cot squared theta? And then plus 1 over root 1 plus tan theta is basically secant squared theta, and we have both of them. So now sine theta, so when you square root a square, you get the original. So cot theta plus 1 over secant theta. So now we have sine theta. So you know cot theta is basically, so the identity we will use here is cot theta is basically 1 over tan theta, and tan theta is going to be 1 over sine theta over cos theta. So which gives us cos theta. So this is basically the reciprocal cos theta over sine theta. So now cos theta over sine, you just write it here. So sine theta divided by cos theta over sine theta plus secant squared will 1 over secant squared is basically cos theta. And now we have sine theta times sine theta over cos theta and then plus cos theta. Let me just get some space over here. Okay, sure. Now what we can just do here is we can write it as sine squared theta over cos theta plus cos theta. So now to make cos theta common in the denominator, we need to multiply this cos theta again times the cos theta, which gives you sine squared theta plus cos squared theta. So the identity here we use is this, so which is basically 1 over cos theta, which is going to be secant theta, which is equal to RHS shown. I hope you understood. We used all the three trigonometric identities over here in this question. So most of the questions involves using multiple identities into your answers or the method you follow. So just make sure you can also refer this from the formula sheet given. Just make sure you can understand those different the variations, so making the subject different. So like cot square theta is basically cosine squared. You bring down the negative 1 to the other side, you get -1. So on and so forth. Okay, let's move on to this question, part B. Given that secant x is this, where we have a domain, what is sine? Find sine x. Okay, we need to write sine x in terms of secant x. So for this question, you need to show the idea of how you are going to convert sine secant x into sine x, which is something awkward because you cannot directly convert it. So what we'll do here is we'll take secant x to be alpha as stated in the question. So what is secant x, which is basically 1 over cos x, is going to be alpha, is going to be 1 over alpha. So 1 over alpha. So this is going to be alpha. This is going to be alpha. So now what is cos x? Cos x will be 1 over alpha. So as now we got cos x to be 1 over alpha. So you can use this identity over here in this question, sine square x plus cos square a equals to 1. So what we do here is we square this cos x to be 1 over alpha squared. So now from here you know that this cos square x is going to be 1 minus sine squared x, which is going to give you 1 over alpha squared. So now we have sine squared x to be 1 minus 1 over alpha squared. Sine x would be positive. You'll first write this plus minus because it's a square root. So now you have this. Now you need to connect. So if you state that this is going to be the answer, of course you're going to be wrong, because you're given a domain over here which you need to follow. So the x cannot be beyond from this domain. So what this domain suggests is, okay, we have 3 pi by 2. So 3 pi by 2 is going to be, so let's just convert it into degrees to make a more clear sense or easier calculations. So what we have is 3 pi over 2, which is going to be 270 degrees x to 360 degrees. And where does this fall into? So this falls into in the 4 quadrants, this falls into the quadrant 4. So in the quadrant 4, is sine x going to be positive or negative? That's what you're going to evaluate over here. So from the formula, you know that A, S, T, C. So A is all the sine, cos and tan are positive over here. This is only sine is positive, and at quadrant 3, the tangent is only positive, and here it's only the cosine positive. So since we are asking about the tan, we just need to consider the negative values of the sine x. Oh, sorry, since they're asking about the sine x, we need to consider only the negative values. So sine x is going to be the negative 1 minus 1 over alpha square. So that's going to be your final answer. So just remember just to omit this positive because of the four quadrant rule and the domain given. So your domain is from 270 degrees to 360 degrees. So in that domain, you only have the negative values of sine x, not the positive ones. Okay, now let's move on to question 11. So hope you understood how to perform these trigonometric functions. And now question 11 is about the series. So an arithmetic progression has a common difference d. The third term of this progression is 10. So you now know that T3 is going to be 10. Write down the expressions for the first term and the second term in terms of D only. So let's say let A be T1. Okay. So to get to T3, what happened here is you added 2 times of D. So a plus 2d from the Tn is going to be a plus n minus 1d. So this is a general formula. And now what we did is you just need to substitute n is equal to 3 and you will get a plus 2d. So, so now what to get a which is T1, you just need to T3 minus 2d, which is going to be 10 minus 2d. So that's your this is the term 1. So A is going to be the term 1. So then T2 is going to be 10 minus 2D plus D, which is going to give you 10 minus D. So that's a very straightforward answer. So just I've elaborated on the explanation a bit. So how do you transpose from T3 to T2 to T1? So let's move on to part B now. When each of the first 3 terms are squared, so remember that each of the first 3 terms are squared. The sum of these squares are 140. Is 140. Find the 2 possible values of D. Using your answer in part A, find the sum of the first 200 terms of this with a smaller value of D. So they just give you another information to solve D. So what they told is when you so you just when you square all the terms and take the sum of it, so 10 minus 2D squared, that's your term 1. Term 2 is 10 minus D squared plus 10 squared. This gives you 140. So this is the equation you need to construct from the given knowledge in the given information in the question. Sorry. So now what we do, you expand. So you will get 40D plus 4D squared plus 100 minus 20D plus D squared plus 100 equals to 140. So now we have 5D squared plus minus 60D plus 300, and then you need to negative the 140. You bring the 140 to the other side. So 300 minus the 140 will give you plus 160 equals to 0. So now you can simplify this further because since the right hand side is 0, you can factorize this by 5 because, okay. So now this is going to be 12D plus 5 3s are 2. Okay, so that's your equation for D. Now you just solve the quadratic equation to get the 2 values of D. So which will be D minus 8 and D minus 4. So D is equal to 8 or D is equal to 4. So you got the 2 values of D. The second part of the question says to use the answer in part A. the smaller value of t. So we are going to use this value of t for this part. So to find the sum of the 200 terms. So here you just it's straightforward. So from this d you can just calculate the ta. So a is going to be 10 minus 2d. So 10 minus 2 times 4, which will give us 2. And now to find the s of 200, so the sum of the first 200 terms, you use the formula again. You need to do 200 divided by 2. So what's the formula for Sn? Sn is a by 2. Uh, so let's just refer to the formula sheet again. So here it's half of n times 2a plus n minus 1d. So that's your formula. So half times n is going to be 2. So let me just write this n by 2, or we can write it as n by 2, 2a plus n minus 1d. So you write 200 by 2, 2 times a you got as 2 plus n minus 1 is going to be 199 times the 4, which is the smaller value of b. And then you just calculate, you will get an answer of 80,000. So remember to do this by steps. I have skipped some steps over here to because it's a non-calculator paper. You of course need to do it with steps. Okay, now let's move on to the last question of this video and for this paper. In this question, n is greater than or equal to 6. Use an algebraic method to show that n choose 5 minus n minus 1 choose 5 can be written as n minus 1 choose 4. So you just need to use the formula of the combinations to apply in this question. So the combinations formula is, let's say n choose m. It's going to be n factorial over m factorial times n minus m factorial. So this is what we are going to use here. N choose 5 minus n minus 1 choose 5, n factorial over 5 factorial times n minus 5 factorial minus n minus 1 factorial over 5 factorial, and then n minus, okay, and here it's going to be n minus 1 minus 5, which gives you n minus 6 factorial. So now what we can do here, so what we can do here is we can write this as n factorial over 5 factorial. So you can need to separate some of the terms over here. So you can write this as n minus 5, n minus 6 factorial. So there's the common terms over here, which you need to derive before separating it. So then 5 factorial. So here you can write this as n times n minus 1 factorial, and then n minus 6 factorial. So the common terms, when you factorize it, you'll get n minus 1 factorial over 5 factorial n minus 6 factorial times n over n minus 5 minus 1. So now we can make it into same denominator. So basically this n minus 1 factorial, n minus 1 factorial over 5 factorial. You just leave this as it is. we are going to focus on this part. We can make this into the same denominator as n minus 5, which will give us n minus 5, which is going to be 5. So that's what we did. Now what we can do here is to basically write this n minus 1 factorial as n minus 1, n minus 2, or wait, I don't need to do that, I think. So we can write, you can just cancel out this 5. So this becomes 4 factorial in the bottom. And then this 5 goes. And now when you separate this is going to be n minus 5. So let's just look into this part. So now we need to look into this part. So 1 over n minus 6 factorial. So this is basically, you can make this into n minus 5 over n minus 5 factorial. So how did we get that? Is basically we do this 1 over n minus 6 n minus 5 factorial. So that's from here to here. And now you just need to multiply both sides by n minus 6. So n minus 6 on the top will minus 1 would be n minus 5. And then in the bottom n minus 5 factorial. So that's how you get that. So now what we can write it 4 factorial. We have n minus 5 on the top and then n minus 5 factorial on the bottom. We have 1 over n minus 5. We can cancel out these two. And now we are left with 1 over 4 factorial n minus 5 factorial. Now you need to make this into what they ask, and choose n minus 1, choose 4. So to do that, what we need to do is you just need to add 1 to here and n minus 5 here. So what I'm saying here is, so okay, and what we need to multiply this, both the denominator and the numerator, by n minus 1 factorial, n minus 1 factorial, n minus 1 factorial. Yeah. So now you can write this as n minus 1 factorial over 4 factorial. You can just leave it as it. N minus 5 factorial times n minus 1 factorial is basically, you can just write it as n minus 4 factorial, because 5 and 1, when you expand it, you will get it to be n minus 4 factorial. So now we have the form, the combinations form for the with the equation. So this aligns with the general form over here. So now what we do is we can just write this n minus 1 choose 4 shown. There's a lot of steps over here, so I have just simplified it here. It's not, I have not written every detail. So this is an important part. You need to first know how to convert factorials in different forms. So as we saw here, we can convert 1 over n minus 6 factorial to be n minus 5 over n minus 5. So you need to always keep in mind your endpoint and which one do you want to cancel out. So here we wanted to cancel out the n minus 5 and n minus 5. So that's why we made it into this equation. And then when we wanted to convert it to n minus 1 choose 4, we needed the n minus 5 factorial over here to be n minus 4. So that's why we multiplied it by n minus 1 factorial on the top and the bottom. So hope you understood question number 12 and hopefully all the questions in this paper. If you have any doubts or if you have missed the previous part, you can check the description box below. So for the previous video for the questions from 1 to 7, and hope you enjoyed the lecture and see you soon in the next video. Bye bye.